In the previous video, we looked at the unit circle for degrees, so in this one we're going to look at radians. One thing that tends to confuse people is they've never really seen the word radians before. And it turns out radians is just another way to measure the angle of something. So just like if I were to ask you how far away you are from your computer right now, you might say that you're a few feet, or you might say that you're a few meters, or some other. There are multiple ways of measuring that. Feet, inches, meter, all of those are still going to measure distance. Well, degrees and radians are both going to measure angles. So throughout the video, we'll actually discover that there's a way to convert, if you'd like to convert those degrees and radians, or we can kind of think about it and figure out how those radians are organized on the unit circle by just doing a little bit of thinking. So real quick, something to remember is the unit circle is a circle, as the name implies. And one thing that I tend to do to remember about what radians are is I remember that the circumference of a circle is equal to 2 pi r. And the circumference is the distance around a circle. So if you got a circle and you wrapped a piece of string around it, it would take 2 pi radiuses to get around the full thing. And that's actually a really important bit of information, because a radian is defined by that statement. So let's take a look at our unit circle that I've got out here. Again, if you didn't watch the last video, this isn't to scale, it's just something quick that I put up in order to help us see some things. These colors personally help me as I go through. They might help you, they might not, but this is just something to help us view those little angles as we go through. So just like with degrees, your radians are going to start at the standard position. Notice we don't really have any units. For radians, we could put RAD, but most people just leave that off, and if there's no units on it, it's considered to be a radian. With degrees, you always have the degree symbol up at the top, but again, with radians, we tend to not put anything. Now, if we think back to that circumference idea, a radian is measuring the arc length of this. So one full circle is going to be 2 pi radians. Think about that equation. 2 pi r was the circumference. So 2 pi radians is going to be one full circle. Once we know that relationship there, we can kind of figure out the whole unit circle the same way we did with the degrees. Halfway between 0 and 2 pi is 1 pi. So then if we figure out, all right, well, halfway between 0 and pi, we could write 0.5 pi, but we tend to like fractions when we're dealing with radians, so we end up with pi over 2. And this is again where people tend to freeze. A lot of students don't like the idea of having pi, and a lot of students don't like the idea of having fractions. But when we're dealing with radians, we end up using those a lot. So getting comfortable with adding and subtracting fractions, and adding and subtracting with pi, is going to make your life a little bit easier. So that might be something you want to practice going forward. So let's go ahead and do the same thing we did with degrees. If you watched the last video, we were able to figure out these red angles by saying that we traveled 90 degrees to go from 0 to here, another 90 degrees to go from 0 to here, and one final 90 degrees to go from there to there. Well, this time, instead of doing degrees, we're going to use our radians. So here I'm going to do the same thing, except instead of 90 degrees, we use pi over 2. Add another pi over 2, and add one final pi over 2. When you're adding or subtracting fractions, you have to make sure that the denominators are all the same. Since I have the same denominator, I can just go ahead and copy that denominator over. Now I add the numerators, or subtract if we were doing a subtraction problem. Pi plus pi plus pi, that means I have 3 pi's. So this angle down here ends up being 3 pi over 2, because we've got 1 pi over 2, 2 pi over 2, 3 pi over 2. So again, I'm going to erase this so that I can keep my workspace nice and clean, but really we're just adding a pi over 2 for the first quadrant, pi over 2 for the second quadrant, pi over 2 for the third quadrant, and we end up with that 3 pi over 2. So 3 pi over 2. We've officially filled out all of the quadrantial angles. Again, that's just a fancy word for saying your axes angles. So now, in the last video when we were dealing with degrees, we said that this blue line is going to cut the quadrant in half. So we need to ask ourselves, what is pi over 2 divided by 2? And some of you may be able to just straight up say, oh, that's pi over 4. Others of you might want to see this. So I'm going to go over here and prove that. Pi over 2 divided by 2. Well, anytime I've got a fraction inside of a fraction, it's totally okay to think the words keep, change, flip, but the official mathematical way of saying it is multiplied by the reciprocal. So again, I'm okay with everyone thinking to themselves keep, change, flip. That's an excellent way for you to remember how to do this. But anytime my students say keep, change, flip, I cringe a little bit. So I want them to say multiply by the reciprocal. That's the official math way to say it. So let's see what that means. If you're thinking keep, change, flip, it means that you're going to keep your numerator, pi over 2, change division to multiplication, and flip the denominator. Well, one issue that people run into is this is a whole number, so there's nothing to flip. But remember, every whole number is actually a fraction in disguise. So now we can see if we flip this fraction, we end up with 1 over 2. Now in order to multiply, it's going to be pi times 1 and 2 times 2. So here we've proved that pi over 2 divided by 2, you're going to multiply by the reciprocal and get pi over 4. So using the same ideas that we did to solve for the degrees, we can solve for the radians. I'll go ahead and erase this just so that again I can keep that board nice and clean for us. So let's go ahead and do again what we did with the degrees. We said from 0 to the blue is pi over 4. Then from blue to red we travel another pi over 4. So really this becomes 0 pi over 4, 1 pi over 4, 2 pi over 4, which reduces down to pi over 2. Adding another pi over 4 gives us 3 pi over 4. Adding another one gives us 4 pi over 4, which is an equivalent statement, so good, we're on the right track, we haven't made any sort of mistake. Adding another one gives us 5 pi over 4. Adding another one is going to give us 6 pi over 4, which is equivalent to 3 pi over 2. Adding another one gives us 7 pi over 4. And last but not least, we should end up with 8 pi over 4, which reduces down to 2 pi. So if you look carefully at it, let me go ahead and write this one in just so we get the idea. You actually have 0, 1, 2, 3, 4, 5, 6, 7, 8. Because all you're doing to jump from the quadrantial angles to these blue ones right here that split it in half is you're adding 1 pi over 4. So it makes sense that all of these numerators should end up going up. So again, for the sake of keeping it nice and clean, I'm going to go ahead and erase the extraneous information here. Extraneous is just a fancy way of saying extra. So we filled out the quadrantial, we filled out the blue. Now we're down to the green and the yellow. Well, in the last one, when we were doing degrees, part of what we recognized was that these green and yellow lines split these quadrants into thirds. So if we take pi over 2 and divide it into thirds, again we need to multiply by the reciprocal. Keep the numerator, change division to multiplication, flip the denominator. Multiply across. Pi times 1 gives you pi, 2 times 3 gives you 6. So when you split this quadrant into 3 equal sections, each section is going to cover pi over 6 radians. So we can use that information to fill out the rest of the unit circle, just like we did with the 30 degrees. We added 30, we added 30, we added 30. Added 30, added 30, added 30. But now instead of 30 degrees, we add a pi over 6. So here's 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 7 pi over 6. Oh, darn it. Sorry, let me erase that. I can't count for some reason today. Got 0, 1, 2, 3, 4, 5 pi over 6. We've got 6 pi over 6. Then we go up to 7. Here's 8. Here's 9. Here's 10. Here's 11. And here is 12. Now again, we can double check ourselves as we go through by reducing these fractions. 0 pi over 6 reduces to 0. Pi over 6, 2 pi over 6. Some people may have already recognized that you can reduce this down, and it ends up becoming pi over 3. So now we look at the next one, 3 pi over 6. That does reduce down into pi over 2. Again, these quadrantial angles, we already know what the answer should be. So if we mess up like I did over here, the reason I paused is because I recognized that if I added 1, I wouldn't get 6 pi over 6. And that's why I make sure to do all those quadrantial angles first. It's unfortunate that I messed up, but it's actually really good for you guys to see that you can check yourself as you're going through. I know that I'm correct over here because 3 pi over 6 reduces to pi over 2. Over here, 4 pi over 6 is going to reduce down to 2 pi over 3. 5 pi over 6 doesn't reduce down. 6 pi over 6 reduces to pi, which is what this should be. 7 pi over 6 doesn't. 8 pi over 6 does reduce down. It's going to go down into 4 pi over 3. Now I look up here, 9 pi over 6 does reduce down into 3 pi over 2, so I know I didn't make a mistake in here. 10 pi over 6 does reduce down into 5 pi over 3. 11 pi over 6 doesn't, and 12 pi over 6 does reduce into 2 pi. So let me go ahead and erase a lot of this extra stuff here, and we'll bring it down to brass tacks so you guys can see exactly what the radians on a unit circle should look like. So I'm erasing all the stuff that isn't reduced down fractions so that you guys can see exactly what we need to be looking at here. So up here we have pi over 3, 2 pi over 3, down here we end up with 4 pi over 3, here is 5 pi over 3, and that right there completes all the radians for the unit circle. In the next video we're going to be looking at what the coordinate points are. So if you remember at the very beginning I said imagine yourself with the y-axis here and the x-axis here. We're going to fill out what these coordinate points actually are.